Okay, so we're doing Hacker Frog's After School Cryptography Basics session number 6. So let's go ahead and get the link just in case anybody wants to watch along with us on youtube.com. And let's go ahead and grab that link. Here it is. I'll just leave it in the chat for everybody. Okay, so let's go ahead and get started. So today we're going to be using PicoCTF. So if you don't already have an account over at PicoCTF, please make one over there. And we're going to be working over there a little bit later today. All right, so this is Cryptography Basics number 6. This is the last class for cryptography for this course, but hopefully you've all learned a little bit about these secret messages that we send back and forth called cryptography. And we're going to be learning about something that is very relevant to real world stuff as far as cryptography is concerned. Anyways, hey there, Hacker Frogs. This is the workshop. This workshop is the 6th and final session for Cryptography Basics. And in the last session, we learned about the following cryptography concepts. So we talked about a few different things last time. We talked about the XOR operation, and XOR is a bitwise operator which can be performed between 2 or more numbers and returns the number 0 if the bits are the same and 1 if they are different. We talked about some different XOR properties. So A XOR B is the same as B XOR A, and A XOR two other numbers is the same as the two other numbers XORed with the first number. So if you're able to get two of the numbers that were used in the XOR operation, you can get the third number pretty easily. So in this session's topics, we're going to be talking about the RSA crypto system, and we're just going to do an overview of it. I can't say that I'm an expert on the RSA crypto system, but it does come up a lot in CTF challenges. So we need to learn a little bit about it so that we're able to complete some of these challenges. And we're going to be talking about a couple of, well, we're going to do one challenge at least from the PicoCTF website that covers the RSA crypto system. So let's talk about the RSA system. And RSA, this is going to be an acronym for its creators. So it's three people created this system over here. Mr. Ron Rivest, R, Mr. Adi Shamir, S, and Mr. Leonard Edelman, which is A. So this comes up as RSA. And this is a public key crypto system. So when we're talking about public key crypto systems, we mean that there are two keys that are used to decrypt a message and to encrypt a message. So when you want to create a secret using RSA, you need a couple of different keys. We're going to talk about what these keys are and what role they play in just a second. So what is this public key cryptography thing we're talking about? In a public key crypto system, each party, which is the sender and the receiver, they're both going to create a public key and a private key for encryption and decryption purposes, then exchange their public keys. So we can probably better understand this if we talk about a little example. So in this example, we've got Alice and Bob. So Alice and Bob, they're going to exchange their public keys to do their public key cryptography. And if Alice wants to send Bob an encrypted message with public key cryptography, first the two would exchange public keys. So for cryptography, they both have these public keys. They're going to share them with each other. Then Alice encrypts her message to Bob using Bob's private key and sends, oh, okay, sorry, I made a bit of a mistake. So Alice encrypts her message to Bob using Bob's public key. This should say public key. And so basically, both Alice and Bob have a private key as well, and they combine the information in their private keys with the public key of the person that they want to send the message to. So after they do that, they can send it on over, and then you can get. We'll explain this. So Alice takes her message and then uses Bob's public key to encrypt the message, and then sends it to Bob. Even if the encrypted message is captured, it cannot be read since it's encrypted. So the important thing about the RSA system is that if somebody captures the message, then they cannot read the message because they would need to have the private key of whoever it's being sent to read the message. Okay, so upon receiving the message, Bob can decrypt the message using his private key and then can read the message. If Bob wanted to respond, he would encrypt a message using Alice's public key, etc., etc. So Bob decrypts Alice's message using Bob's private key and is able to read Alice's message. So public key cryptography is widely used on the internet to secure systems such as HTTPS, SSH, and VPNs. So when we say HTTPS, what we mean is web pages. So in most cases, when you connect to a web page, your browser and the web server is going to do public key cryptography to make sure that the messages sent back and forth between you and the website are going to be encrypted. So the same thing with SSH, and SSH is basically logging into a computer that is not your own computer. And with SSH, the same thing happens. There's going to be encrypted message sent back and forth, which means that if anybody were to intercept these messages, then they wouldn't be able to read the messages. And the same thing with VPNs. So we talk about VPNs, we talk about them being private, and the way that VPNs are private is that the VPNs create an encrypted tunnel, which where data is sent back and forth, and so anybody who was to capture this information, they wouldn't be able to read this information. So this is all examples of public key cryptography, and they're used in a lot of different systems to make sure that the data is nice and secure. So what about hacking with RSA? So although RSA is considered to be a secure method and it's very popular and it's a secure method of encryption, it is possible to decrypt RSA messages if the key was created insecurely, and we're going to go over one of those examples right now. So even though RSA is a secure method of encryption, we have to be careful that we don't use RSA in an insecure way, because if we were to use RSA in an insecure way, then people could potentially hack it and then get the information, the original message. So there's something in RSA called a cube root attack. This is an example of how RSA could be hacked. And a cube root attack is a cryptographic attack which takes advantage of the small public exponent in RSA encryption. So when we say small public exponent, we basically mean how complicated the value is that we use to encrypt. And in this case, there's going to be three things that we can get from an RSA message, and those are the values of N and E and C. So N is going to be the key basically that is sent along with the message. The value of E is going to be the complexity of how we're going to be doing the mathematics on the encrypted message to decrypt the message. And there's the actual message itself, which is C over here. And in this case, C is, well, in all these cases, they can all be expressed as like a number. So in this case, N is a number, and so is E, and so is C. Anyways, if we're able to successfully do this cube root attack, then the encrypted message can be read without the use of the private key. So to determine if a specific message encrypted with an RSA public key can be vulnerable to the cube root attack, there are two conditions that must be met. And in this case, the two conditions are going to be that the exponent, or the E value, used in the public key must be sufficiently small. So if you configure your RSA encryption in an insecure way, such as making this E exponent value very, very small, then that could be a big issue when you're trying to keep your messages private. So the second condition is that the ciphertext, or C, and in turn the plain text M is sufficiently short. So if we're sending a very small message, then this could also be a very bad thing when you're trying to make your message secure. So in a lot of cases, sometimes even if the message is very short and very small, they'll try to pad out the message by adding a bunch of extra information to it to make sure that everything is bigger and thus more secure. So we're going to be using an example over at PicoCTF to illustrate how we can do these attacks on the RSA crypto system. So let's go ahead and go over to PicoCTF. So let's go ahead and move over to the website. So this is PicoCTF. And the first thing we're going to do is we're going to open up a web shell. So the great thing about PicoCTF is that we can use the web shell when we're solving the challenges. And the web shell is basically a Linux computer that we can use from the internet. So this is what we're going to do. After we've logged into PicoCTF, we can click on the practice page over here. And then after that, we're going to click on the web shell button over here. If you can't see the web shell button, then you can scroll down a little bit, and then you'll be able to see the web shell button over on the right-hand side. So after that, click on the web shell button. And you should see this message right here. It should say, welcome to the PicoCTF web shell, and then you can see that your name is going to be here. So your username, in my case, is the Shy Hat, and then PicoCTF, add web shell. And what we want to do is we want to make the web shell nice and big, because right now it's only taking up about half the screen, and we really want it to take up the full screen. So we can make the web shell large by clicking on this button over here. So in the web shell, next to the help button to the right, there's going to be this button over here labeled Pop Out Web Shell Terminal. So you can go ahead and click on that. And then the web shell is going to appear in the browser tab, in its own browser tab, nice and big. Kevin Johnson on LinkedIn says, "Hi everyone, RSA cryptography rocks." Yeah, it sure does. Thank you very much for coming by, Kevin Johnson. And let's go ahead and so if for some reason you clicked on the pop out web show terminal button and it didn't work, what you can do is you can try again. And sometimes it might not work the first time. You might want to try it a few times, and eventually you'll be able to make your web shell terminal nice and big in its own browser tab. So if you manage to make your web shell terminal big, please let us know in the chat by typing in the chat, web shell is big, smiley face. Okay, great. Nice to see, nice to see. Okay. All right, so let's go ahead and continue on. So we're going to be doing user V. Okay, I see. Changes to an emoji. That's not a bad thing. And we're going to be doing the RSA challenge. So RSA, I think it's called mini RSA. This one right here. Okay, so this is the link. I'll leave it in the chat. Just in case you were wondering, this is challenge number 73 in the list. Globby Guy on YouTube. Hello, nice to see you here, Globby Guy. So we're just going to be solving a little challenge over here, and this is mini RSA. So what I want you to do is I want you to click on the link, and then that'll take you to the challenge. This is called mini RSA, and we're going to try doing the cube root attack on the RSA system. So this mini RSA challenge here, it's a hard challenge from the cryptography category from the PicoCTF 2019 event, and the description of the challenge says this. So let's decrypt this ciphertext. Something seems a bit small. Okay, so what we can do is we can highlight the link over here. So there's a link in ciphertext. Go ahead and right click it and then select copy link. After that, you can go over to your web shell. So in the web shell, you can type wget and then space, and then paste in your file link. So it's going to look like this. Wget space, paste in the file link, and then hit enter, and you should download this file called ciphertext. So after that, you're going to see the ciphertext file in here, and we're going to be inspecting this file in order to do the challenge. So to read the file, I want you to type in cat space ciphertext. When you do that, you're going to see three values over here. There's going to be n, which is the key, and then there's going to be e, which is the exponent, and there's going to be c, which is the ciphertext. So the ciphertext, this is the actual message that we need to decrypt. The rest of this is just some information about how the message was encrypted, and we can use this information to decipher the ciphertext over here. So with this information here, we could do a cube root attack, and if the ciphertext is small and if the exponent is small, so if either the exponent or the ciphertext is really, really small, then we could potentially be doing this cryptographic attack. And in this case, the E value over here, this is really small. So it's, yeah, so this value is small, so we can go ahead and we can assume that we could potentially do this cryptographic attack. And I have a little Python script to do the attack, and you can find it over at this link over here. So these are the session notes for today's class. They've got the PicoCTF link. They've got the walkthrough link over at YouTube, and then we've got our method of solving the challenge. So in this case, we're going to be creating a little Python script called minirsa.py or .py. So we can go ahead and go over to our web shell, and in the web shell, we're going to create the file with nano. So the nano text editor. So you're just going to type in nano and then mini_rsa.py. That's going to start up the nano text editor. So the next thing we're going to do is we're going to grab the code for this script. So the code is going to be over at the GitHub page, and we can go ahead, go to the GitHub page, and then there's going to be, under step 2, there's going to be this code over here. So the code, we can copy this. So to copy it, all we need to do is click on this button over here. It's going to copy all the code, and we're just going to go into the web shell again, and we're going to paste in the code. So just right click and select paste, and this is going to paste in the code. So what is this script doing? We should probably talk about what the script does so that we can understand what's going on. So we can't do we can't do the mathematics required to do this cryptographic attack by hand because, well, there's a lot of big numbers and big math. So we're going to be talking about how the script works, and because the script is going to be doing the heavy lifting for us. So the first thing that happens is we import some modules over here, and then we've got the values for what information we have. So we've got the values of n and e and c, and we're going to try to compute the cube root of c. So the cube root of c is going to be the ciphertext over here. So if this is a perfect cube, then we can do the attack. We run a little function over here to figure out if this is a perfect cube, and then if it's a perfect cube, we use the information here, the N and the E, to do the attack. And if it's successful, then we're able to get the plain text for this message from the ciphertext over here. Okay, and let's go ahead and save the file. So we can save the file by doing Control X, and then it's going to ask us if we want to save the modified buffer. The answer is Y for yes. Hit Enter to save the file. So after that, we should have our mini rsa.py file here ready to go. I want you to cat the file, or rather read the file with the cat command over here. So cat mini rsa.py. If you see the code over here when you give the cat command, please let us know by typing in the code is, the code is ready. Smiley face. As usual, if you're having any troubles getting this, if you're having any troubles or if you got stuck at any point, then let us know in the chat and we'll try to help you out. Okay, great. Let's see. Dark says the next digital forensics. Bope, or BOEWP says the code is ready. Okay, let's go ahead and run the script, and hopefully we can get the flag from the file over here. So just type in Python mini _rsa.py, and it actually gives us the decrypted plain text over here. So this is going to be the M value, or the message value. So this is the plain text value. This is the plain text value in decimal, and this is the plain text value in ASCII text. So here's the thing. The information in ciphertext, in the ciphertext file over here, it's not going to be the same for everybody. So if you're having troubles, and if you try to, well, this might not be your flag, because the flag might be individualized. If you find that the system doesn't accept this flag, you're going to have to go back into the script, and you're going to have to substitute in these numbers over here from your ciphertext file. So your ciphertext file might not be the same as my ciphertext file. The beginning of the flag is going to be the same, but this part of the flag over here might be different. But you know what? Just for fun, I want you to try submitting the flag over here. And if it says that the flag is not the same, then let me know. If the flag isn't the same, it doesn't accept it, you're going to have to substitute in the numbers, your own numbers, from the ciphertext file in order to get it done. So the ciphertext and the N value over here, you might have to put in your own. Okay, so we can go over to picoctf. We can submit the flag. Oh, that's not the flag. It's not the flag at all. Let's go back. Here it is. Paste it in, submit the flag. Okay, so let's talk a little bit about how exactly we can do some encryption of our own if we wanted to do this inside of Linux. So on Linux, you can encrypt messages using RSA as well, and you would do so using the OpenSSL program. So let's talk a little bit about how we would do this. So we would give a command kind of like this. So OpenSSL, and then the first step is we're going to create a private key of our own. So we're going to generate the private key, and we're going to specify that the algorithm is going to be RSA, and we're going to create a key called private key.pem, and we're going to give some options over here. we're going to make sure that this is an RSA key that's created using 2048 bits. Okay, so it creates a private key for us. So if we have a private key, then we could start, well, first of all, we could get a public key from this as well. And then we can start encrypting some messages. So I'll just leave the command that I used right now over in the chat. And you can try out this command yourself. It's going to create a file called privatekey.pem. So privatekey.pem is, if we use the file command on it, so this is, it says this is ASCII text. If we read the private key, so this is the private key over here. It's been encoded using, well, it's been encoded using base64. So what we could do, if we really wanted to, is we could decode this using base64 as well. So just for fun, let's try decoding this from base64. And remember that base64 is a very common, oh, that didn't work. Okay, you know what? Maybe we can do this. So we're just going to base64 decode the private key.pem like this. So it says base64 invalid input. Okay, you know, I really want to try decoding this. Okay, I'm going to copy all of this. So you can do this yourself. You can just copy from the start of the thing up until the end, but before the end private key over here. So I'm just going to copy this, and we can go to a website on the internet. There's lots of websites that are going to decode base64. So just type in the search box base64 decode, and there's a website called base64 decode. You just paste in your information here, click on decode, and what does it? So this isn't, it looks like this information isn't meant for us to look at, but it's meant for the computer program to look at because they've got a bunch of unreadable stuff. Dark says echo code base64 decode. That's correct. That is correct. The problem is that it's a bit tricky to do inside the terminal because there's all sorts of line breaks and stuff. Okay, so, oh, this isn't the right place. We should be in the web shell. Okay. So now that we've created our private key over here, we can actually get a public key. We can extract it from the private key. And this is the command we're going to use. So we're still using OpenSSL. We're going to do public key out, and we're going to get it from the private key.pem file. We're going to output public key.pem. Okay, and then after that, we've got a public key. So what's in the public key? Let's try reading it. So this is another base64 encoded key. Okay, so with the public key and the private key, we can start encoding some messages. And you know what? I forgot to give you guys this this command over here. So this is going to be the command that is going to create the public key. So Dark on YouTube says random. Volcano says 4 keys. Are you able to decode them easier? So this is the thing. We're going to be feeding the public key and the private key to the OpenSSL program. And the OpenSSL program is going to do the encryption and the decryption for us. But the first thing we need to do before we can encrypt and decrypt our messages is we need to create these keys. So we just did that with the previous 2 commands that we did. And we created these 2 files. So Oh, I made an extra file here. Okay, so you should have a private key.pem file and a public key.pem file. And the next thing we need to do is we need to, oh, thank you very much for following on Twitch. Marwin K1, thank you. And let's see. The next thing we're going to do is we're going to encrypt a secret message using these keys over here. So what I want you to do is you can create any message you want to. And maybe we can do nano space message.txt. So this is going to bring us into the nano text editor. When we're in the nano text editor, we could create any message we want. So in here, I'm going to create a message. It's going to be hacker frogs rule, hack the planet. What else is something that hackers like to say? Leet is an awesome number. Okay, so type whatever message you want, and then we're going to save the file. To save the file, do Control X, save modified buffer, press Y for yes, hit enter to confirm, and we should have a message.txt file now that has whatever message you created in it using the nanotext editor. We're going to encrypt this message using our public key and our private key, and then we're going to decrypt the message as well. So this is what we're going to do. We're going to do the following command to encrypt the message. So it's OpenSSL pkey utility encrypt in file is going to be message.txt, and we're going to provide the public key, and the public key is going to be public key.pmem. We're going to output a file called encrypted.bin, bin for binary file. Okay, so here's the command here. I'll give it to everybody else. Okay, so after we do that command, we're going to have an encrypted.bin file in here. So encrypted.bin, this is the encrypted file. If we run the file command on it, it just says there's data in here. It doesn't actually know this is an encrypted message. And if we try to read the file using the cat command, we're not going to be able to figure out what this is. The reason why is because this has been turned into binary data, which is data that we can't read by default. So if you were to receive a file like this, you wouldn't know right away that this is an encrypted message. So what you want to do is you want to decrypt the message, and we can decrypt the message with the following command here. Okay, so Dark, nice to see that you're having fun. Okay, so the message, the way to decrypt the message is we're still using the OpenSSL program. So this time it's going to be OpenSSL, and then pkey utilities, and then decrypt. We're going to put in the encrypted.binary file. We're going to provide the key. So it's going to be private key, and we're going to output the decrypted, we're going to call it decrypted.txt. So let's run this, and let me give the command to everybody so you can try it out yourself. Okay, so we've got a bunch of files in here. We created a bunch of them, and we've got encrypted sorry, we've got decrypted.txt here. So if you were to read decrypted.txt using the cat command, then we get the original message over here. So remember, we created the message over here in message.txt. Then we encrypted it and created a file called encrypted.bin. And then finally, we decrypted the message and we created a file called decrypted.txt. So if you manage to successfully do that, and you manage to decrypt the message and get your original message back, let us know in the chat by typing in I encrypted using RSA, smiley face. Just for fun, maybe not just for fun, but I should probably include these in these instructions in the GitHub file. So let me just edit this really quick. Okay, so let's see. This section we'll call encrypting using RSA in Linux. And then let me just type in my commands. What were my commands? Just a second. So the first thing you need to do is you need to create, actually it's going to take a bit of time. Maybe I don't want to make everybody wait here. I'll do that after the class is over. Okay, but anyways, let me go ahead and save this out. Okay, so here's another thing we could do. We could also try doing some encryption using the XOR the XOR operation. Anyways, there's a sorry, there's a ad going on Twitch and YouTube right now. So I'm going to run an ad on YouTube, and we're just going to take a minute and have a little water break. So if you need to get up and stretch, use the washroom, have some water, that you can do that right now. We'll be back in about a minute. But in the meantime, you can check out this this bird bath over here. Enjoy the birds. We'll be back in about a minute. Oh, that's not a bird bath. Hold on, that's a cat. Let me put on the right one instead. Okay, we'll be back in about 30 seconds. I love these little American robins because they always look so they always look so serious. They always have a very serious look on their face. Anyways, let's put the birds away. Let's continue on. Welcome back. Thank you. Thank you. Okay, so another thing we could do is we could try doing some XOR operations to conceal some messages as well. So we covered XOR in the previous class, and I've got a little script over here that we could use for XOR. Let me go ahead and grab that. So XOR is another concept we're going to run into a lot when we do cryptography, and this is the link for the script. I think we used this one last class as well. So what I want you to do is I want you to go over to this file here, and I want you to copy the file. You can copy the file by clicking on this button over here. So the button is 2 squares that look like they're on top of each other, and it's labeled copy raw file. So if you click on that, you can go back, after you do that, you can go back to the web shell, and in the web shell, you're going to create a file called zor. Well, let's call it frogzor. Frogzor.py. So we're going to get into the nanotext editor. We're going to paste in our code, and we're going to, inside the code here, the code basically encrypts or does an XOR operation between two strings. So we got the message bytes over here, and the message bytes is basically the information we're going to start with, and the key bytes is going to be the key that we're going to be XORing with. So the last time we took a look at this, we figured out that if the key is short, then if we get the ciphertext, we could potentially figure out what the key is by taking the ciphertext and doing an XOR with the message bytes over here. Sorry, the ciphertext and then XOR with what we suspect might be in the message. So in this case, let's go ahead and try making a message. So the message bytes, we're going to do, well, we could do any message we want in between these double quotes here. So hacker frogs rule, and this is a secret message. Okay, just like this. So for the key, if we wanted to make a secure key, we have to make sure that the length of the message over here and the length of the key is about the same. So the only reason why we were able to get the key back from the message over here in the last class is because the key was really short. So this is something that we need to be careful of when we're doing the XOR encryption. So we can change the key bytes. We can make it something really long. And in fact, if we, I don't know, how many characters is this? I'm going to guess this is 10, this is 20, this is 30, maybe this is 40 characters long. And so for the key bytes, we're just going to do 1 to 40. So that's 10, that's 20, that's 30, that's 40. So definitely don't do something like this for if you're actually creating a secret message, because this is kind of predictable right here. But anyways, okay, so let's go ahead and let's see. We're doing a XOR between the ciphertext and the partial plaintext. In this case, the partial plaintext, let's go ahead and change this. Let's change this to the key bytes. Actually, wait, which one should we do? B-House, I see you, and we'll see you next time. We'll see you next time. Okay, so the partial plaintext, well, in this case, we know, let's just pretend that we know that the word hacker frogs is going to be at the beginning of the message, right? So for the partial plaintext, we can put in hacker frogs. So hacker frogs, we're just going to include this as the partial plaintext. Remember that if we need to give bytes in this case, so we need to make sure that each one of our little strings here is going to be have a B at the beginning before the double quotes. Okay, we can go ahead and save that out, and we can run the script. So the script is frogzor.py. So just run python space frogzor.py. Okay, so it says here the ciphertext hex string is this. And the bytes that come out here is we know that there's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. You know what? This is still insecure. I'm sorry. This is actually still insecure. Hmm. That's interesting. I think what we can do is from here. So I accidentally made an insecure key one more time. We can go back into frogzor.py, and if we go back in here, so we know the partial plain text. Instead of the partial plain text, we're just going to put in the key that we know. So the key that we know was the 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So this is actually a repeating key. And if we just put in here for the partial plain text, well, this isn't going to be plain text, this is going to be the key. We're just going to guess that it's this because we did the XOR operation between this and this. So we're going to save it, and then we're going to run it again. So we were actually able to get most of the message because we were able to guess at the partial key over here. So that's so that's interesting. Okay, so before we finish out today, let's talk a little bit about what we learned in today's class. So back here, so we talked about an introduction to the RSA cryptography system. So this is so RSA basically stands for the people who created the system. So there's going to be Revest, Shamir, and Edelman. And this is a public key crypto system. So if you remember, in a public key crypto system, each person who's going to be sending messages using the system, they're going to need a private key and a public key. Dark says, flag RSA makes my brain crash. I think if you were to play around with RSA some more, it'll become easier after a while. I'm not an expert in RSA by any means, but we have to understand a little bit about it because it comes up a lot when we're talking about cryptography and when we're talking about cybersecurity stuff in general. So we're talking about the RSA hacking via cube root attack. Although RSA is considered secure, it can be hacked if it's used with insecure settings. So this is actually something you're going to see a lot in cybersecurity because in cybersecurity, people will have something that's already secure, but they'll mess around with it. And when they're messing around with it, they'll make it insecure. And this is it's something that happens a lot. Anyways, so one such attack that could be used against the RSA system is the cube root attack. So in this case, because one of the values that is used to create the keys was very small and very predictable, we could do this attack. So what's next? So this is the end of our Hacker Frogs After School Cryptography course, but tune in next time when we're starting a new course on network hacking. So next class, we're going to be covering a new topic. It's going to be network hacking, and this is my favorite thing. So we're going to be exploring around networks. We're going to be talking about how networks work, and we're going to be talking about doing some hacking against these network environments. So this is actually kind of related to something we're going to be doing next today after in the next hour of today's stream. And we're going to be taking a look at this website over here because they've got a bunch of little lessons that teach you about about computer networking. And let me just leave the link for this. Bope says, what if the n is a small number and the exponent is a big number? Is it still insecure? So the n is always going to be a really big number. You can't really have a circumstance where the n is a small number. And let's see. User V says, is computer networking like how people talk online? So computer networking is basically the foundation of the internet and how everybody communicates with each other online. Because computer networking is all about computers that are connected together. And because computers are connected together, there's a bunch of systems in place that talk about that. For example, we can talk about like an IP address, and IP addresses are basically how devices on the internet find each other. And we can talk about the DNS system, which basically is like the phone book for the internet. And it lets you know that google.com has this IP address. And if you want to contact google.com, you have to contact it using this IP address, et cetera, et cetera. And there's a lot of stuff here on these in these little lessons here over at Hacking Hub. And if you don't have an account over at Hacking Hub, you can go ahead and make one. You don't have to pay anything to make the account, and you can get a little precursor for what we're going to be covering in our computer networking and attacking course. When I say attacking, um, well, we're going to be learning about computer networking. We're not necessarily going to be attacking anything, at least not in the first few lessons. The first few lessons are basically going to be talking about what computer networking is and how to use computer networks in a regular way. Because if you can't use the services in a regular way, you're not going to be able to do hacking instead. Because hacking is all about understanding a system, and after you understand the system, then you can potentially hack the system. Okay, so everybody, we're going to be finishing up our lesson over on Zoom, and for everybody on Twitch and YouTube, we're going to be taking a little break, and after a few minutes, we're going to come back, and we're going to be taking a look at these networking lessons. Okay, so for everybody on YouTube, we're going to be back in a couple minutes. Please enjoy the music and enjoy the Be Right Back screen. We'll see you in a little bit.